Just how did the earth, our home, and the place where life as we know is evolved, come to be created in the first place? The earth is thought to have been formed about 4.6 billion years ago by collisions in the giant disc shaped cloud of material that also formed the sun. In one part of space, there is a huge collection of stars mixed in with massive clouds of gas and dust that today we call the Milky Way galaxy. In a small corner of that huge galaxy, in an area that would later become our solar system, there was a big cloud of gas that had been swirling around since the Big Bang. There were also some dusty remains of an old star that had exploded long ago. The gas and dust were floating, swirling, and spinning past each other, but they were all quite far apart. But then a nearby star exploded in what we call a supernova. This supernova sent a shockwave of light and energy rippling across space, pushing some of the gas and dust towards each other. This gas and dust soon became a ball which started to get bigger and bigger because of gravity. Gravity makes everything in the universe move towards everything else. And when things get really big, like planet size big, they start to pull all nearby things towards it. Gravity slowly gathered this gas and dust together into clumps that became asteroids and small early planets called planetesimals. As the ball of gas and dust got bigger, the gas and dust collected to crush in on itself until something called a nuclear reaction happened right in the middle of the ball. A nuclear reaction is super powerful, and this particular one turned our sun into a brilliantly shining star, throwing light across the rest of the gas and dust that was still spinning around it. Gas and dust started clumping together to form planets. Some of those other swirling, twirling chunks of gas and dust that hadn't been sucked into the sun were bumping and clumping into each other. Soon those clumps got big enough that gravity started pulling in all the other gases and dust around it, all while still going round and round the giant shining sun. Some of these twirling bits clumped together to make our Earth. Others clumped together to make Mercury, Venus, Mars, Jupiter, Saturn, Uranus and Neptune, and all of their moons too. All these baby planets swirled and spun and pulled in all the nearby matter. They squished together to become super tight, big, giant, hot balls of spinning stuff. Our own Earth was getting hit by rocks that were falling towards it. It kept getting bigger and hotter until it was a giant ball of melted rock. Then a really huge rock smashed into Earth and made it even bigger. And a little bit of that rock flew off and floated into space to make the moon. So the Earth was just out there floating in space near the sun. But it looked totally different to the Earth we live in today. There were volcanoes all over the place with hot lava and gas everywhere, cooling down. But slowly, over many years, Earth started to cool down. Some rocks full of ice and gas hit it and melted to make the sea. This is continuing today. Every year, more than 3 tons of space rocks hit the Earth. But slowly, over many years, the top layer of the Earth was cool enough to harden. This is the ground we walk on today. We call it the Earth's crust, like a crust of bread. Deep down underground, the Earth is still full of melted hot rock. And gradually, over a long time, plants started to grow, bugs started to live, and life on Earth began to form, which is a whole story on its own. Earth is really ancient, and humans have only been around for a tiny part of that. All the buildings and cars and restaurants and phones and even everything that's inside of you, it all started with an exploding star billions of years ago. An eon refers to a span of 1 billion years. The first era in which the Earth existed is what is known as the Hadean eon. This name comes from the Greek word Hades, which means underworld, which refers to the condition of the planet at the time. This consisted of the Earth's surface being under a continuous bombardment of meteorites and intense volcanism, which is believed to have been severe due to the large heat flow and geothermal gradient dated to this era. Outgassing and volcanic activity produced the primordial atmosphere, and evidence exists that liquid water existed at this time despite the conditions on the surface. Condensing water vapor augmented by ice delivered by comets accumulated in the atmosphere and cooled the molten exterior of the planet to form a solid crust and produce the oceans. It was also during this eon, that is roughly 4.48 billion years ago, or about 70 to 110 million years after the start of the solar system, that the Earth's only satellite, the Moon, was formed. The most common theory, known as the giant impact hypothesis, proposes that the Moon originated after a body the size of Mars, sometimes named Theia, struck the proto-Earth a glancing blow. The collision was enough to vaporize some of the Earth's outer layers and melt both bodies, and a portion of the mantle material was ejected into the orbit around the Earth. The ejecta in orbit around the Earth condensed and, under the influence of its own gravity, became a more spherical body, the Moon. The Hadean eon ended roughly 3.8 billion years ago with the onset of the Archean age. Much like the Hadean, this eon takes its name from an ancient Greek word, which in this case means the beginning or origin. This refers to the fact that it was during this period that the Earth had cooled significantly and life forms began to evolve. Most life forms today could have survived in the Archean atmosphere, which lacked oxygen and an ozone layer. Nevertheless, it is widely understood that it was during this time that the most primordial life began to take form, though some scientists argue that many life forms may have occurred even sooner during the late Hadean. At the beginning of this eon, the mantle was much hotter than it is today, possibly as high as 1600 degrees centigrade or 2900 degrees Fahrenheit. As a result, the planet was much more geologically active. Processes like convection and plate tectonics occurred much faster, and subduction zones were more common. Nevertheless, the presence of sedimentary rock date to this period indicates an abundance of rivers and oceans. The first larger pieces of continental crust were also dated to the late Hadean or early Archean eons. What is left of these small continents are called cratons, and these pieces of crust form the cores around which today's continents grew. As the surface continuously reshaped itself over the course of the ensuing eons, continents formed and broke up. The continents migrated across the surface, occasionally combining to form a supercontinent. Roughly 700 million years ago, the earliest known supercontinent called Rodinia began to break apart, then recombined 600 to 540 million years ago to form Pannosia, then finally Pangaea. This largest supercontinent broke apart 180 million years ago, eventually settling on the configuration that we know today. Since that time, a mere blip on the geological timescale, all the events that we consider to be recent history took place. The dinosaurs ruled and then died, mammals achieved ascendancy, hominids began to grow, slowly evolved into species we know as Homo sapiens, the humans, and civilization emerged. And it all began with a lot of dust, fire, and some serious impacts. From this, the sun, moon, earth, and life as we know it were all created.